everything really needs to be properly clean and free of all kinds of little particles. Got to be clean. Now, we have our aluminum jaws that are they're marked back and front, and we can take this here. Back. Okay. Now, we're going to just double check, make sure we have a clean of our rice. Looks good. Place our part in here. We have a little step on the aluminum drawers to hold our part, and we're going to bring this in gently. You can close it. I'm going to bring this part out so that we can find part 0. Our part 0 for our coordinate system in absolute is going to be this back left corner over here. And the reason for this is the industry prefers the back jaw, or the part of the vise that's not movable. You should never take a 0, 0 or use a coordinate system off a movable jaw. It does not repeat. Everything should be off a stationary point. And I want to use the vise side, or the side of the part, and this part of the part. Coordinate system 0, 0 is at this corner. Be sitting like so. So, I'm going to just snug this up. And we're going to use, for part 0, 0, you need to use a work offset sheet. And I'm going to use G154P2 for my work offset for this particular job. Now, what we're going to do is, we'll put in a tool, very nice handy tool, that will help us find part 0. That's our X and Y coordinate system, and we're going to put it in the worksheet 154P2. Okay, now we are going to, we have highlighted 154.2, it's in the x-axis. So what we're going to do right now is bring the probe, our finder, to get this edge and this edge. And we just need to bring the ball down. So I'm going to come down and hand jog to Z. Now I'm going to come over in the X. I'm going to do the X first. And that's about right. Come back down a little bit more. And if you were to look, you would see that the ball is approximately, the diameter of the ball is going to make contact on the vise and the plate at this point. Okay, now, this is done simply by our tool. We're going to come over in the X. We're going to slow it down. And we watch our needle. When it reaches 12 o'clock, that's 0. At this point, we're going to put in part 0 measure, but we're going to look at our position page, offset page rather, and we're going to make sure we're on the X, 152. Our X is saying minus 18, or the machine is minus 18,487. This number should go in here. We push part measure 0, and sure enough it goes in. That gives us our 0 reference point exactly on that surface. This tool takes everything into consideration. You don't have to worry about turning the machine on, subtracting 100 or adding 100 depending on your reference point to find 0 with a edge finder. An edge finder of that type looks like this. This is an edge finder, and this thing goes in the spindle. It has to rotate at about 600-800 RPM. It works, it's fine, but I don't particularly like it because you have to have the machine running. That makes it a little bit dicey when you have new people. You got to be very careful. This, on the other hand, the machine does not have to run, and you get everything exact. So we have our X. We need to find our Y. Okay, the Y, I want to use the edge of the plate because the ball will have difficulty reaching this surface over here on the back of the vise. So I'm going to come out. And we're going to come in on the Y. The minute it starts to move. We're going to slow speed. Okay. We're at 12 o'clock. We are now at Y0. And we're going to put this measurement in the machine. Y is saying it's going to be minus 2 inches, 8824. We hit part 0 and it puts it in. We now have our coordinate system from the machine to our point of 00 for our part for machining. Okay, now the machine knows exactly where our part 0 is. We need to put the tools in to do the job. And our tools of selection for today are going to be tool number 1, a 1/4 inch. Tool number 1 is going to be a 3/8 end mill. We're going to use a 90-degree center drill. We're going to use a 201 drill. And to be the tap hole for the tap, we'll put our tap in, which is going to be number 4. And that's the plan of action for the moment. Okay, first thing we need to do is call up tool 1. Okay, what we're going to do is go MDI T1 tool check. Okay, now I'm going to give you a brief situation as to why we like to do this. In the industry, we like to take our measurements off a surface that we can depend on if we have to go back in the middle of a job in case the tool breaks, something happens. If we take our tool that's off the top of our work, which is 0, which we need to make 0, and we will make this 0 by an adjustment, but if we take all the measurements and we use our tools here, we can always replace the tool very easily and within seconds. If we use this as our 0 and this becomes unusable surface, if it's contoured and you can't go back in here and you break a tool in the middle of the job, you can't go back here. You may have to replace the plate, put it in, it's a big ordeal. But if you take them from here, everything is fine. You can replace tools, change tools, adjust tools, you can do whatever you choose. So, I like to use this tool offsetter. The permanent number for this is 5087 when this is at 0. From the bottom to here when this reaches 0. I'm going to put this here. Our first tool is going to be tool 1. And we're going to take this. I like to use this balance hole to the left to the carousel. And we're in. Now, we have to get our tool to the tool setter, which is done like so. We go into the line. I like to put it right here. Then we'll come back over. come down to the Z's. Gotta go a bit slow here. Come back out in the Y. Okay, in the industry we like to use just one flute, but in this particular case I'm going to use the entire surface of the tool. And we're going to come down, Z. Now, when we get close again to 0, go a little slower. That's where we want to be. Tools on the offset is at 0. Now we're going to simply close the doors. You can't operate the machine with them open. We're going to hit tool offset measure. It's going to take this and put it in there and measure. So we have 65326, 65326, we're ready. So the next tool we want to put in, we go to next tool. Our next tool, or our second tool, is going to be the center drill. And we'll put this guy in. And we'll come down to the Z. And we're going to go tool offset measure. It's going to put it into 2. Fine, 27858, we're good. Then we'll go to the next tool. And our third tool is going to be the drill. Again, bounce onto the carousel. Make sure it's clean. Can't have anything on this. And we're going to come back down. And take it to there, slow it down a little more. Okay. Our geometry is going to be 4, 1143, spindle 3, 1142, tool measure, puts it in, next tool. And our fourth tool is going to be our tap. And make sure that this is clean. In. And we're going to bring her down. And that should be it. And we can put our tool offset measure 48055, 48043. We're going to put that in, tool offset measure. She's in on spindle 4, great. And we'll go to our next tool, which is going to be 2.5, but we're not going to use 2.5. Although it's in here, at the moment we're not going to use it. Okay, so we have our 5 tools offsetted in. The machine now knows where all the tools are with reference to this surface. So now what we want to do is we want to find the difference. The way this works is we know the offsetter was 5087. So we'll come back down here to our area, and we're over here on the Z-axis, and we know that the tool offsetter was minus 5087 from Z0. By the way, machine 0 is over in the left-hand corner, all the way to you and all the way to the left. The Z0, spindle 0, is always at the height for a tool change. Anything down is minus, anything away from 00 machine is going to be minus also. That's why if you notice everything's in the minus. Okay, what I want to do right now is I'm going to put in the tool offsetter temporarily, and the tool offsetter is going to be minus, we're going to have minus 5 inches, 0.087. This here, we're going to go enter, but the problem is it's not going to do it. It's going to ask us because it's more than 1 inch. I want to put it in, the answer is yes, and she's in, 5087. Now all we need to do is very simply find the difference between this surface and our actual plate machine 0 surface. Okay, for this particular last adjustment is we need to get a reference from here to the 0 of your plate. And that's simply done, you could use a height gauge, or we can go back and we can reuse our tool. This also can find that. Now, what we need to do is go to our position page. We need operator. Let's see. Operator. Okay, we're on operator. And what we want to do at this point is make that surface 0. Okay. Slow it down. Okay, now we need to make this 0, so we must be on the z-axis. We're on the z-axis with the z key, and we put 0 in, and we go to origin key, which is here, and that should make this 0. Oh, I see. Hold on. Let's go over here. 0. 0, origin. Okay, we're 0. Now, as we go up, notice the numbers are changing. We're going to come up higher, and then we're going to bring our table out. I like to go a little closer to our 0, 0 plate on the plate. And we'll come a little bit closer to here. And we're going to come back down nice and easy. And we start to touch. And we now have a number here. The distance from this surface to this surface is going to be 1 inch and 43. So we want to combine this with this. And because it's positive, it's going to make this number less negative. So we're going to come back up in the offset again. Okay. We're highlighted. Notice the yellow is on the highlighted part of the z-axis geometry. Your work offset 0. And we need to correct that with this number. So we're going to put in 0.0043. Now, when I input this number, it's going to reduce that, but it may not do it because it's bigger than 1 inch. It is, but that's what we want. We'll press yes, and it goes in, it reduces it to minus 40827. Now, this machine knows where every 0 is, knows your starting point, knows where all the tools are. All it needs now is the program.